So let's look at a few more examples where we need to classify triangles by both their side lengths and by their angles. So we have triangle EFG, this triangle right here, and let's talk about its lengths first. So notice that it has a 6, a 7, and an 11 millimeter side. So these are all different. And when they're all different, we call this a scalene triangle. If two of them were the same, it would be isosceles, and if they're all the same, then it's equilateral. Now, looking at its angles, we basically just want to look for the biggest one. So that's this angle right here. And notice that if we draw in a right angle here, so that would be a 90-degree angle right there, this is bigger than that. So our biggest angle is an obtuse angle. So we would refer to this as an obtuse triangle. So this is a scalene triangle, and it's an obtuse triangle. So let's look at a couple more examples. So this triangle right here is a little bit tricky. Now, what you can notice is that all the side lengths are the same. So going by that, we can call this equilateral. So it's definitely an equilateral triangle. And when we have equilateral triangles, all the angles are equal as well. In fact, these are all 60-degree angles. So that's true of any equilateral triangle. So since all of the angles are less than 90 degrees, we would say this is an acute triangle. Remember, an acute angle is just an angle less than 90 degrees, and we only have those. So this is an acute triangle. Now, the tricky part of this problem is that there is a third classification. Since we defined isosceles triangles as having at least two equal sides. And notice, if you pick any of the two sides, they are equal. But since we're saying it has at least two equal sides, that would also include equilateral triangles where all the side lengths are equal. Since remember, isosceles triangles have two equal sides and two equal angles, or we can say at least two equal sides and two equal angles. So this triangle would fit that definition as well. So therefore, this is also an isosceles triangle. So there are actually three different answers, at least going by the modern definition of an isosceles triangle. Again, if you look at the ancient definition that was given in Euclid's Elements, this would not be isosceles because by that definition, isosceles triangles have exactly two equal sides and two equal angles. So it really depends by what definition you use, but again, the modern definition uses the qualifier at least, so it can also include equilateral triangles. So let's do one more example. And this one, we can notice it has two side lengths that are equal. So that means this is an isosceles triangle. And looking at the angle measures, so this one is a little bit hard to tell. We're looking at the biggest angle. So we know in isosceles that these two angles, the ones that are opposite the two equal sides, those are both equal to each other. And then we have this third angle here, and this one is probably the biggest. Sometimes it's hard to tell with the picture. So what we need to ask is this angle bigger or less than 90 degrees? And if we try to draw a line in here that forms a 90-degree angle, it looks like this is less than 90 degrees. Sometimes with the picture, it's going to be a little bit difficult to tell, but it looks like in this case that this is less than 90, and this is the biggest angle, or at least it looks to be the biggest angle. And in fact, it is the biggest angle because it opens to the biggest side, but that will come later. And since this is the biggest angle and it's less than 90 degrees, we know this is an acute angle, which makes the entire triangle an acute triangle.